Now, this is going to be a quick review on using the zero product property or factoring to solve a quadratic equation. And a review because this has come up in earlier classes. All right. So the key to this, to solving using the zero product property, is the zero product property. And here's what the zero product property says. Let's say I've got two numbers. All right. I'm thinking of two numbers. And I need you to guess my two numbers. Now I'm going to give you a clue. I'm going to tell you that when I multiply these two numbers, I get 0. Now, can you guess one of my numbers? Well, you should be saying, yeah, I know what one of those numbers. I know one of them has to be 0. Maybe the other one's 15, or maybe it's 1.7, whatever. Doesn't matter. You know one of them right away. One of them is 0. Okay, now it could be that one, or it could be the other one over here. You don't really know, but you could guess one of the numbers is 0. So if I tell you they multiply to 0, you know one of them. Now think about this real quickly. This is important. What if I tell you that my two numbers multiply to 10? Can you guess one of my numbers? Well, you're going to have a hard time guessing even one of my numbers, all right? Because maybe I was thinking of 0.5 and 20. Those were my two numbers. All right, did you guess that? Probably not. So if I have two numbers and I tell you they multiply to 10 or some other number, you don't know what it is. But if I tell you they equal 0, then you know either A equals 0 or B equals 0. And that's a hugely useful and important property called the zero product property. All right, so the key is this. If I have an expression or an equation that says these two things are multiplied, remember these parentheses here mean that there's multiplication going on in between. So these two things multiply to 0. Well, what does that tell you? That tells you that either this first part, x plus 3, is 0, or this second part is 0. So we know that one of those has to be 0. So we can make two equations from that, and we can say either x plus 3 equals 0, and we can subtract 3 from both sides, and that will give us the answer x equals 0 minus 3, which is negative 3. Or x minus 1 equals 0, the second one. So we can add 1 to both sides, we get x equals 1. So we see that if it's in this form, it's really nice, because if these two things multiply to 0, one of them has to be 0. We can make two equations. All right, well, what if it's not in that form? Well, if we have an equation that's not in that form, here we have a quadratic equation. It's quadratic because it has x squared. Then what we can do is this. We can start by making one side equal to 0. We got to have one side equal to 0 first. So we got to subtract that 30, get everything over. If there were x's over here, we got to get everything over to the left. Now it's equal to 0. So we got x squared minus 2x minus 35 equals 0. And we've got to factor this, all right? So you've had some experience with factoring. And so remember, when it's in this form, when we have an a value of 1, that number in front is 1. We're looking for two numbers that add to negative 2 and multiply to negative 35. Start with looking for multiplying. And the two numbers that multiply to negative 35 are, well, there's 7 and 5, there's 1 and 35, and that's about it, I guess, right? Okay, and so if we look at those numbers and look at their sum, we land on 7 and 5. Negative 7 plus positive 5 makes negative 2. So there it is. So now we've factored it. And so now it looks like the previous problem that we just did up here. Okay. We have two things that multiply to 0. So the zero product rule says if these two multiply to 0, then make the first one equal to 0 or the second one equal to 0. Add 7. You get x equals 7. Subtract 5. You get x equals negative 5. Okay. So that is solving by factoring. A nice tool there to use. When it works, it doesn't always work. But when it does, it's nice. Let's try these here. A couple quick examples. All right. Solve by factoring here. Let's add 9 to both sides. And we get x squared minus 14x plus 49 equals 0. Now we ask ourselves, can we factor this? If we can't, we're kind of stuck. But I think we can. Two numbers that add to negative 14 and multiply to 49. Well, numbers that multiply to 49 are 1 and 49. I don't think those add to negative 14. And how about 7 and 7? Ooh, 7 and 7 make 14. So maybe it's x plus 7 and x plus 7. Oh, but wait a minute. Those don't add to negative 14. So if we change these to a negative 7, all right, I think we'll be in luck. So negative 7 or minus 7 and minus 7. That works. Okay. Again, when we say that works, remember the big idea is we can distribute this out and we get x squared minus 7x minus 7x plus 49, and that gives us x squared minus 14x. Don't worry about writing this. Plus 49. All right. So this and this are exactly the same. All right. So that's the key. All right. We're going to erase that because that was just a quick check. If you want to check it, you always can. All right. So now we know that either x minus 7 equals 0 or x minus 7 equals 0. Now, because it's a repeat, you don't actually have to do this twice, but that's the idea. Add 7 and x equals 7, and obviously this one gives us x equals 7 also. So there's one answer in this case, x equals 7. There you have it. Okay. This one's already equal to 0, and so we've got to factor this. Now this one's a little more challenging. The reason why it's challenging is because we have an a value that's not 1. So to factor this, we can do this a couple ways. We can first do kind of a trial and error, or a guess and check method, some people call it there. All right. And so we know that whatever this is, it's got to multiply out to this. All right. So kind of trial and error, we could say, you know what? I don't. Maybe this is. I know the first two numbers have to multiply to 6x squared. So maybe it's a 2x and a 3x. I don't know. And I know the last two have to multiply to negative 5. All right, so that could be a plus 1 and a minus 5, or it could be the other way around. Okay, now the key is that I know that these multiply to negative 5 and these multiply to 6x squared. All right, but will I get negative 7x when I multiply this out? I don't know. Let's see, that's going to be, if I multiply those two, I'm going to get 3x. And if I multiply 2 and 5, I get negative 10x. Now it's negative because of that. Do those add to negative 7x? No, but you know what? I'm really close. And the only problem is the sign. I would like this to be, oh, no, wait, I'm right on. What do you know? Now, I just guessed the right one, so my first trial landed on it. And so that's nice because these numbers are pretty small. So sometimes you can land on that, but you got to check. Don't forget to check that these actually add up. Notice that negative 10x plus 3x is negative 7x. That's great. Okay. Now, if I would have made this one negative and this one positive and tried it out there, I would have gotten positive 10x and negative 3x, and notice those don't add to negative 7x, so that would have been my mistake right there. I would have caught that and said, oh, I got to fix it. It's not negative, it's not positive. Okay, so now I wouldn't spend too long on that. I mean, if you know, we're going to try that. If you don't land on it, then you know, try the AC method. All right, so real quick review on the AC method. AC method goes like this. The AC method says we take a times c, and that is 6 times negative 5. 6 times negative 5 is negative 30. And we look for two numbers that add to negative 7 and multiply to negative 30. Now those numbers are 10 and, actually negative 10 and positive 3. So what we're going to do here is we're going to rewrite the equation 6x squared, and we got our minus 5 But we're going to take that middle term and we're going to write that as negative 10x plus 3. Because negative 10 and 3 multiply to negative 30. They multiply to negative 30 and add to negative 7. Okay, now again, this is different because there's a 6 in front, not a 1. All right, so here, now we've got 4 terms. Oops, I forgot my x, or lost my x somehow. There it is. All right, so what we're going to do is we're going to factor by grouping here. So we're going to group these into 2 parts. We're going to pull out a common factor. What's a common factor here? Well, there's a 2 in both and there's an x. So 2x, and that gives us 3x minus 5. Now here, I got to pull something out so I can pull out a 1, all right? So that seems kind of silly, but you'll see why. We want to pull something out. And then we say, all right, notice we got a common factor. So there's a 3x minus 5 in that first part and a 3x minus 5 in that second part, all right? So we're going to pull out the 3x minus 5, and we're left with 2x plus 1. All right. Well, there we have it. Now we got 2 parts that multiply to 0. So 2x plus 1 equals 0, or 3x minus 5 equals 0. Okay, we know one of them has to be 0, and we can solve this up. And 2x equals negative 1. And we can divide by 2. And x equals negative 1/2. There's one answer. We can add 5 to both sides here. And now we can divide by 3. And we get x equals 5 over 3. Leave it as a fraction. Fractions are great. Okay. And we say it's one or the other, but you really need to have both. It's not find one or the other. There's 2 answers. All right. Well, there's solving by factoring. All right, so we want to check when we're solving quadratic equations, can we factor it? And remember, the key here is the zero product property. That's what it's all about. Do these 2 things multiply to 0, then one of them has to be 0.